Welcome back for our continued discussion on limits. Today we're going to talk about infinite limits. As you can see, the definition is written there. A limit in which a function increases or decreases without bound as x approaches c is called an infinite limit. Let's look at an example here of that. Let's see, sorry for a second there. Let's get rid of that. I want that box to go away. There we go. Make a small line here. Sorry, now let's get going. So f of x equals, let's just say, 3 over x minus 5. And we want the limit as x approaches 5 of f of x. Well, we know that's an issue. I can't plug 5 in there. Okay, can't factor, can't rationalize, can't do any of that good old stuff. So our only option is to create a table or look at the graph. Okay, and for this purpose, we're going to create a table, or we're just going to think about it logically here. All right, so let's approach from the left first and see what's happening. So from the left, that's numbers like 4.999. Right, so if I plug in 4.99, I'm going to get 3 divided by 0.01. That's 3 over 1/100th. That's 300. Actually, I stand corrected. Negative, negative. Now what if I add another 9 on there? 4.999. Now I have 3 divided by negative 0.001, or negative 3,000. So as we can see, this is going to keep increasing. If I give another 9, I'm going to give another 0, and another 0 here. So this is actually heading towards negative infinity. It's decreasing without bound. Similarly, if I choose to come towards 5 from the right-hand side, number slightly bigger than 5. Now it's going to be 3 divided by positive 0.01 and 3 divided by positive 0.001. This is going to head to infinity. And hopefully that should make sense with what you guys already know about that graph. Right? That's a parent graph right there of the reciprocal function. And a reciprocal function for this particular one is shifted to the right 5 units. So over here at 5, I have my vertical asymptote, and my graph looks like this. The horizontal asymptote at 0. The vertical we saw is at 5. And my x-intercept is at what? Negative 3/5. Sorry, my y-intercept is at negative 3/5. Okay, notice from the right, we're heading towards infinity. From the left, we are heading towards negative infinity, as we stated here and here. All right, let's move on to another definition here. Vertical asymptote. If f of x approaches infinity or negative infinity, as x approaches c from the right or the left, then the line x minus c is a vertical asymptote. And that's a typo in there. And I read the typo. This should say x equals c is a vertical asymptote. Make sure you make note of that change there. Not x minus c. X equals c is the vertical asymptote. And you're going to have tons and tons of situations like that. Let's take the example of cotangent of x, for instance. Cotangent, we probably are more familiar with thinking of cotangent as cosine over sine. Well, I know that sine can't have values of pi over, or of 0 or pi, because I get 0 in my denominator. So the limit as x approaches 0 of that function would be interesting to see. So I want to approach x from the left and from the right. So as I approach from the left, now this is tricky because you're thinking unit circle here, right? So if I'm approaching 0 from the left, let's get a circle going here. All right, so I'm going to approach 0 from the left. That's actually values below it if you're thinking the unit circle. All right. So approaching 0 from the left of f of x. So cosine of 0, I can plug that in. I get 1. But sine of 0, when I'm coming from values smaller than 0, Sine is down here. It's really, really, really close to 0, but it's in the fourth quadrant, so it's negative. So negative really, 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 really close to 0 gives me a huge negative number. Likewise, I can plug 0 in from the right, and I get 1 over. Now, from the right, this one was from the left. From the right, those are numbers bigger, angles bigger than 0. When I plug that in, I'm going to get a positive value for sine, and it'll be really close to 0 again. That gives me positive infinity. All right, so graphically, for tangent, and I'm going to show you this graph on the calculator here just because it'll look so much nicer than what I can do freehand. If I'm graphing the cotangent, that's the reciprocal of tangent, but I'm going to graph it as cosine divided by sine. We'll do it that way. I could also do 1 over tangent. And my window, I'm really concerned with approaching 0, so I'll go like negative pi over 2. To pi over 2. And I know sine and cosine are between negative 1 and 1, so I'm giving myself a little buffer because I know I'm dealing with cotangent. I'll go negative 2 to 2. And let's look at our graph. Oops, I hit table instead of graph. Here's our graph, the tangent coming through. As I'm approaching 0, this guy's heading down. As I'm approaching 0 from this direction, oh, he's coming from up there. So let me look at this window a little differently so I can see where it's heading towards infinities. If I do like a negative 20 to 20, and graph it, we can see that guy heading down towards the infinities even better now. So there's our visual to go with it. As I approach 0 from the right, I'm heading towards infinity. As I approach 0 from the left, I'm heading towards negative infinity. Okay, and that is all limits at infinity are. One set of properties here you'll want to copy down. Let me just bring them into play here. That would be this one here. So some properties to work out, and we can discuss them a little bit more as we come back to class tomorrow. Hope you enjoyed the video.